Hello everyone. We are very excited to present our first demo today. And this demo will be of a real project, for which construction permission has even already been obtained. It is not large, but it is quite complex and has many details, many nuances. Of course, we will not be doing all the details here. Instead, we'll just build the basics, but we'll show how the product works, how convenient it is, and how quickly a similar project can be done, and we will time it all. This project is a small garage for 2 cars, but in principle it is considered quite comfortable. And as we build it, we will see practically all the tools that can be used, how simple and fast it is to do in Timbernetic. And we start with the foundation. Our foundation will be a concrete slab 6.9 by 8.9, and this is for a building size of 7 by 9. And the slab thickness is 100 millimeters. Now I'm hiding the grid, it's not needed, and locking the slab itself from selection, and we'll add walls. These walls in the front will be small, but in essence, they are columns. They will support the front wall, and we need 3 of them. Height 2.55 is the height of the gate. It's added, and now I'll start placing them, and when we see the green highlight, it means it's showing the point where it will snap. And then when moving, we land exactly in the spot we need relative to other elements. However, I'll break down this wall and add studs to it to make it a truly strong column. I'll just stick them on both sides. We'll rotate these and bring them to one level. Everything snapped perfectly. Now we can select all of this and turn it into a group, but it won't be a smart component anymore. Although each of the elements inside is also a smart element, and we can change their parameters. And it will be very good to keep names organized. Also, that makes a great help later. I'll rotate this column. And now I need 2 more like this in the front. To make this, I'll use the array tool. And here we see that I needed to select the last of the elements, place it, and then the distribution will be precise. And the central column is exactly on the building's axis. Now I can add another wall. According to the project, it's 3.4 meters. I'm making the length the same as the slab. In principle, I could have moved it and snapped it in the same way, but there's another option. I can just grab the element by its point and bring it to the exact position I need. Now I will duplicate the same wall, because its height suits me and its position in principle too. I just need to rotate it, place it, move it, snap it to one of the edges. And now to change the size, there's a tool that allows you to precisely bring it out and recalculate the wall itself as a smart component. Now I want to add headers above the gates. I simply add an element, place it in position so that it lands precisely on the surface, also without difficulty. Here it's on the corner, and I need 3 of them. I'll duplicate them with the same array tool. I select the last one and pull it over. Then I have them. After that, I just need to adjust their size so they connect somewhere with an overlap. Okay, this one didn't align the first time. Now I'll just bring it over, setting it to the point that fits. All of this is done very easily without any effort. All the tools adapt, and all the movements, all the snapping are convenient, because all the elements, the snapping happens relative to each other. Managing naming make it easy to use all these elements, understand sizes, and read the bill of quantities in the future. So I am grouping this all together here to keep the elements more organized. And I will also lock them from selection. At this point, I can copy the back wall as it is the right size. This will be the fastest way to get it. And just change the height to create an arch over the gate. Wall is ready. I will need more columns like these to place a beam, which will run along the center axis of the building. I am creating an array of elements again. Rotating them, placing them in position. And now I have the columns ready to place the beam. Just before any other object reduces visibility in the scene, I want to add headers that I will need in the future. This header will support the rafters and will be embedded into the studs, and will play an important role in transferring the load from the roof. To do this, I'll just place it there and resize it so it hits the center of the stud. All that's left is to copy and resize it, and this element will be ready. Now we will add the opening that is the gate at the back according to the plan. Opening width is 2.4 meters, height is 2.2. So this gate is slightly smaller than the others, because it is not intended for vehicle entry. Perhaps some quad will exit here. Cripple spacing is same as stud spacing, so I will simply rotate them, and the cripples will align with the studs. And now I can resize them to automatically adapt the cripples to the wall height. I also want to give the headers a different section, and make them 200 millimeters high. Now I just need to go into the wall component, enter into the group, and move the studs to make them as king and jack studs. And they naturally remain in the wall and bear the load as they would have if they stay in place. Here they are in place, and I can adapt this header in place. But first I will place the beam. I just need to set it onto the columns and adjust the size. Actually, I'm making a slight mistake here, because in reality that beam will consist of two parts and will connect at the column located at 2/3. A brace wall will also be attached to this column. That small wall inside will divide the garage space and add a small area for a workshop. Now I will adapt the size of this element, still using the resize tool, and I'll position it so that it holds the wall at the same time, and its copy will hold the beam. Now I'll replicate this element, select the last one in the array, move it, and they will be evenly distributed. Now I'll copy this wall to create a partition, which will also play a role in rigidity. And the moment I resize it, it will return to its original state, as it's a smart element and it will recalculate itself. Now I'll work on the roof, and I'll start by adding a simple rafter. I'll adapt this rafter size based on the fact that the roof will consist of two rafters that will overlap. I need to give it this overlap size, create two identical rafters, and position them immediately so they are symmetrical relative to the center and don't extend to the very edge of the wall. I'll do this by referencing the wall itself. Now they can be rotated. We will rotate them by 2 degrees, but of course you need to group them first for rotation. Rotate, and after that, position them at the point where they should be. These specific elements will be on the inside of the wall, adjacent directly to the wall. And here they can be precisely positioned on the beam. Now I will ungroup them and start positioning the rafters themselves on the beam. At the same time, they will be in contact with the studs, and their position will be at exactly the same distances as the studs spacing. In this case, it's 60 centimeters. I need to position the first one. And then I will add exactly as many as I need. So the first row is ready. I need to repeat the same for the second one, the only difference being that it will be in contact with the first. In this case, I won't use snapping to find the contact point. We can imagine that many elements used or positioned here will be adjusted or adapted on the construction site. But planning is used to the maximum in order to make setup much more convenient. Now I will adapt these two elements so that they fit and are in contact with the wall on which they will be fixed, and at the same time lie on the beam. Now they can be copied again and added to the other side. In this case, snapping works, and they end up positioned exactly where needed. The movement is performed precisely along the coordinate axis, and consequently, there will be no other displacement. So, the roof is ready, and the wall can be copied. It will be identical. The internal wall also needs to be adapted in size. This is done using the same resize tool. However, we see that the rafters intersect with the studs. Therefore, we need to shift the wall by the thickness of a rafter. Now let's enter the wall component itself, and edit the necessary elements by simply moving them to their proper positions and resizing them using the same tools we normally use for components. All elements within a smart component are also smart elements. We'll do this on both sides since we moved the wall. However, we'll encounter a problem selecting this last stud because it's positioned inside the wall. You can try blocking it from selection, but that still doesn't work. So we'll need to hide this wall temporarily. Perhaps in the future we'll address this limitation by making elements completely transparent for selection purposes when their selection is locked. Positioning here is a bit challenging because the view is too far out. We just need to zoom in and then everything will move smoothly. The wall is now complete. Next we need to add the elements that will support this partitiono wall. But we've already performed a similar operation, the same movements and resizing, followed by array cloning. These elements are also ready. Essentially, all that's left is to copy the headers that the rafters will rest on for the other side. I forgot to click apply here, so I'll need to repeat this operation. Sometimes it's tricky to grab the correct arrow, so you may need to rotate the view to a more convenient position. Here we simply place them where needed. So our basic garage structure is now complete. However, I stopped the timer and forgot to add top plates, so had to restart it. While paused, I took the opportunity to rename the elements to make them easier to identify in the bill of quantities. We definitely need to add the second top layer of plates to connect the walls together. We'll take the usual operations and then adjust the lengths accordingly. Then we'll copy these elements again, since they'll be identical on the opposite walls. When working further on the project, all sizes can be adapted and optimized for available lumber. At the moment, I'm just ensuring there's sufficient overlap at the connection points where the plate joins eye and the wall. Now we'll make the final copies. I'll also group the plates here for more practical organization going forward. And our basic project is complete. Let's see our bill of materials with details. If pricing details were added to elements, they'll appear here so we can immediately understand our costs. Some drawings are also visible. This list can be exported to a spreadsheet file for use in other calculation programs. Timbernetic will also feature a full purchase order management and tracking system. Thank you so much for watching. Your support means everything to us. Join our community on our website, Facebook, and YouTube to stay updated with the latest software features, tutorials, and news. Your feedback helps us build Timbernetic into the tool you need. Let's shape the future of timber construction together. See you in the next video.